So let us look at question number 10 now. Section B, question number 10. A neutron, a proton, an electron, and an alpha particle enter a region of constant magnetic field. So all of them enter the same magnetic field with equal velocities. Equal velocities. Underline that part, equal velocities. All of them are having same velocity. The magnetic field is along the inward normal to the plane of the paper. The tracks of the particles are labeled in the figure. Relate the tracks to the four particles. Okay, so we have the question here. Let us draw the figure. Let us draw the figure. So this is what they have given. What they have given, right? You know, I have an inward magnetic field. I have an inward magnetic field. Into symbol means what? Into means it is into the board. The magnetic field is going into the board. Into the board. So the magnetic field is going into the board. It looks like the tail of an arrow, right? Tail of an arrow. Look at this. You know, if I put a point, this is what? This looks like what? The head of an arrow. The arrow is coming towards us. You see the tip of an arrow, right? You know, dot, no? When you see the dot, it looks like the tip of an arrow. That means the arrow is coming towards us. So the field is coming out of the board. Okay, you'll see this quite often now, right? And this is into the board anyway. These are all into marks. They look like the tails of an arrow, tails of arrows. And then there are four paths. Draw the figure, draw the figure. There are four paths. Path number 1, path number 2, path number 3. And path number 4. Draw these. Right. A. This is A. I don't know which particle is which. You're going to find out. Right. This is B. And this is C. And this is D. This is D. See this. So I have four particles. I'll tell you how to do this. There are four particles. Tell me when you're finished drawing this. So there are four particles. There are four particles. I have to identify the particles from the trajectories, from the paths. Tell me when you're done drawing this. Okay, right. Look at this. You know, the moment I see the question, I have answer to a part of the question. I'm sure that this particle is neutron. How do I confirm? So I had four particles. One was electron. Second one was proton. Then I had a neutron. And then the fourth one was an alpha particle, right? Fourth particle was alpha particle, right? Which were the particles? Neutron, proton, electron, and alpha particle. All right, alpha particle. Last one is neutron. It is alpha particle. Okay, they could even give you a deuteron. Okay. So when you have this question, you know, when you look at this, see this, when you look at this, electron has what charge? Electron has negative charge. Proton has positive charge. Neutron has zero charge. Alpha particle is also positive charge. What is alpha particle? I have told you many times before, alpha particle is helium nucleus. Alpha particle is helium nucleus. See this? It is He24. Alpha particle is helium nucleus. Okay. Alpha particle is helium nucleus. Nucleus means what? Nucleus has what charge? Nucleus has positive charge. Nucleus has positive charge. So I have the four particles here. Electron, which is negative. Then proton is positive. Neutron is neutral, which is having zero charge. Then we have alpha particle. Alpha particle is what? Alpha particle is helium nucleus. Helium nucleus. Okay, right. And you know, what is the Lorentz force on neutron? What is the Lorentz force on neutron? Lorentz force is given by QVB sine theta. They say that all the particles are entering the field. So I have to calculate the Lorentz force. What is the Lorentz force on neutron? I'm checking neutron first. So F is equal to, for neutron, charge is 0, right? Neutron is a neutral particle, right? 0 into VB sine theta, that makes it 0. So Lorentz force is 0 for neutral particles. Lorentz force is 0. That means what? If force is 0, the particle goes undeflected. The particle goes undeflected. Force is 0, no. Force is 0 means the particle goes undeviated. Undeviated or undeflected. So undeflected. So particle goes undeflected in such a case. See this now? The particle goes undeflected. So we are certain about C now. C must be what now? C must be a neutron. C must be a neutron. Neutron. I'm done with first part. So C is a neutron because C goes undeflected. That means there is no Lorentz force. That means there is no charge. That means it has to be a neutral particle. The only neutral particle around is neutron. Okay. And then think about this. Two particles are going to the same side. No, A and B are going to the same side, while D is going to the other side. Okay. So A and B must be of same nature. Both must be either positive or negative. If A is positive, B is also positive, then D is negative. Why? Because they are going in opposite directions. Understand? So the forces are in opposite directions. That is why they are going in opposite directions. Okay. So A and B are identically charged. Nature of charge is same for both A and B, while D is oppositely charged. Now look at this. Same charge comes twice in the case of positive charge, right? Proton and alpha particle, they are both positive, right? So these must be proton and alpha particle. D must be what then? D must be electron. So second part is also done. D is electron. Why is D electron? D is electron because it goes what? It goes in opposite direction compared to what? Compared to the other particles, compared to A and B. A and B should be identically charged. A and B should be what? A and B should be having same nature of charges. A is positive, B is also positive because they are deviated to the same side. But D is deviated to the other side, so it must be of opposite nature. So it is negative. Electron is negative. Now between, so C, I know that C is neutron, D is an electron. Then I have to find between A and B. I don't know which one is which. Now for this, I should think about the equation for radius. Hope you remember the equation for radius. R is equal to, we did this equation, R is equal to mv by qb. Or flip the page to see yourself. See for yourself. R is equal to mv divided by qb. R is equal to mv divided by qb, the radius of the circle. Okay, so I can write this for R proton and R alpha. Tell me what? For proton, I'll write proton's mass as m, velocity is v, charge of proton is c, and magnetic field is b. And what about alpha particle? Alpha particle, I'm writing it here. Alpha particle, see this alpha particle. I'm writing for alpha particle. Alpha particle's radius of curvature. Alpha particle's radius of curvature is what? Alpha particle's radius of curvature. Right. I can put the mass. Alpha particle's mass is what? 4m. Why 4m? Look at the mass number here. Alpha particle is helium nucleus. No, the mass is 4. 4m. Mass is 4m. Mass number is 4m. Into velocity is v divided by the charge. Charge is what? Look at the charge number, the atomic number. Charge number, it is 2. So in place of charge, I should be writing 2e here. And magnetic field is the same because all are entering the same magnetic field. So having obtained both these, I can just divide them. Then if I find the relation, tell me Rp by R alpha. Tell me what you get. Rp by R alpha. mv divided by Eb divided by 4mv by 4mv divided by 2eb. Okay, so I get this m and m cut, p and v cut, e and e are gone, b and b are gone. You get what? Take the reciprocal, 2 by 4. So Rp by R alpha should be equal to 2 goes to numerator, right? 1 by 2. Cross multiply. R alpha will be 2 times Rp. Which means what? Which clearly implies that alpha particle's radius of curvature is greater than that of proton's radius of curvature. Look at that. Radius of curvature of alpha is 2 times that of proton. That means radius of curvature of alpha is double that of proton. So radius of curvature of alpha is greater than that of proton. Whose radius of curvature is greater? Look at this. I can extend this to get a circle. I can extend this to get a bigger circle. Which is bigger circle? Bigger circle is this one, no? Bigger circle is this one, no? While this one is a smaller circle. See this, smaller circle. Smaller circle. No, if I extend this, I get a circle. If I extend this, I get a circle. Which radius is greater? B's radius is greater, no? B's radius. See this. So B's radius is greater means the one with the greater radius of curvature is alpha. So I have the last point. So B is alpha particle. Then the last one is what? A is A is proton. So I have identified all the particles here. So here this part will be a little confusing for you, but nothing. You know, R alpha is greater than RT. See which one is having greater radius of curvature. If I extend this, I'll get a bigger circle. See this. But if I extend this, I'll get a smaller circle. See this. The one with the bigger circle is what? Bigger the radius of curvature. You know, it is for what? It's for alpha. Understand? So the bigger one is for alpha. So that means B must belong to alpha. A must belong to proton. So A must be proton, B must be alpha, C must be neutron, and then D is electron. Okay.